Since 1968, the United Kingdom has maintained a continuous at-sea deterrent. Right now, somewhere in the North Atlantic, a Vanguard-class nuclear submarine is quietly patrolling the waters, carrying the country's ultimate strategic weapon. The system carried on these submarines, the Trident missile, dates back to a procurement decision in the 1980s. When the UK first purchased this capability, the total bill came to roughly £12.5 billion. Adjusted for modern inflation, that's about £23 billion to establish the entire fleet. After that initial layout, the financial upkeep became remarkably steady. For decades, the cost to maintain the submarines, run the naval bases, and service the warheads consumed a highly predictable 6% of the annual defense budget. 40 years of these flat maintenance costs led defense planners to treat the nuclear deterrent as a fixed overhead, a predictable cost of doing business that required no major financial adjustments or structural reviews. But the hardware at the center of that flat line is expiring. The Vanguard submarines have pushed well past their intended 25-year lifespan, and the shoreside facilities that keep them operational are now at the end of their functional life. In a single year, the bill for this maintenance rose by 17%. At £9.6 billion, or $12.6 billion, Britain's annual nuclear spending now exceeds that of Russia, positioning the UK as the world's third-largest spender on nuclear forces. Today, the cost of the nuclear deterrent has nearly tripled its historical share, swallowing up almost 18% of the entire UK defense budget. To manage this massive financial drain, the government consolidated every nuclear-related program into a single mega-budget known as the Defense Nuclear Enterprise, or DNE. This budget is ring-fenced, meaning its funding is legally protected from wider departmental cuts. The DNE moves nuclear spending away from a standard departmental line item, creating a dedicated channel for a scale of expenditure that previous budgeting models could no longer contain. To understand where this money is going, we have to look at the platforms themselves. Here at the BAE Systems shipyards in Barrow-in-Furness, 30,000 people are working on the single largest engineering project in the UK. This is the Dreadnought-class. It is the next-generation ballistic missile submarine designed to replace the aging Vanguard fleet, currently under construction deep inside these sprawling assembly halls. Designing and manufacturing 4 of these massive vessels comes with an official baseline estimate of £31 billion. Because of the technical risks involved in nuclear submarine construction, the government set aside an additional £10 billion contingency fund, meant to absorb unforeseen costs over the project's multi-decade lifespan. But the Dreadnought program is consuming capital rapidly. Before the submarines even cleared the early delivery phases, the Ministry of Defense had already accessed over £3.3 billion of that emergency safety net. The replacement fleet is supposed to carry the UK's deterrent into the 2060s, but it is rapidly eating through its financial reserves years before the first submarine even touches the water. While the submarines provide the delivery platform, the weapons themselves are developed in a separate network of high-security research campuses, the Atomic Weapons Establishment in Berkshire. Currently, the UK is attempting to design a completely new sovereign warhead called Project Astraea. This program alone has been allocated £15 billion of funding just for the remainder of this decade. Astraea requires entirely new manufacturing and assembly facilities, and constructing these highly specialized buildings has triggered the most severe budgetary failures of the entire nuclear program. Project Mensa at Burkefield, designed for warhead assembly, is currently running 7 years behind schedule and has accumulated a £1.2 billion cost overrun. At Aldermaston, an enriched uranium facility named Project Pegasus suffered from technical designs that were too complex to execute. Supply chains failed, and the final cost nearly tripled, from £634 million to £1.7 billion. A planned plutonium facility, Project Aurora, faced similar shortages of highly skilled labor and resourcing bottlenecks, pushing its estimated cost to £2.3 billion. To manage these sprawling delays, the government recently grouped these failing Aldermaston initiatives together, absorbing them into a single consolidated procurement framework called the Future Materials Campus. The physical infrastructure required to process nuclear materials and assemble warheads has become the true driver behind the DNE's financial escalation. With both the submarine platforms and the warhead facilities drawing heavily on reserves, the 10-year forecast for the UK's nuclear enterprise has been upgraded to a total of £128 billion. When independent watchdogs map out the whole life costs, stretching from construction to final decommissioning in 2070, they project the total bill will likely surpass £200 billion. Because of the DNE's ring fence, the Ministry of Defense is legally bound to fund these nuclear programs at the expense of other departments. Money can flow into the nuclear budget to cover overruns, but it cannot flow back out to conventional forces. The overall defense budget is finite. When 18% of the available cash is locked away for submarines and warheads, it directly drains resources from the conventional surface fleet. This conventional squeeze manifests as budget shortfalls for standard troops, resulting in delayed procurements for basic non-nuclear equipment and deteriorating military housing that hurts recruitment. The UK is committed to a modernized nuclear deterrent, but the financial gravity of the project is hollowing out the everyday military it relies on.